Thank you and good afternoon. Today I'm going to talk to you about a study that we did looking at two antimicrobial interventions as we looked at them for use for implant validation. In the United States in 1999, the Food Safety and Inspection Service declared E. coli 0157H7 an adulterant on non-intact products. And so what this required beef processors to do was to start looking at what type of antimicrobial intervention they could apply to the whole muscle products prior to making them non-intact. Now, when we talk about non-intact products, we're talking about any whole muscle for which you're going to penetrate the surface of that raw product. And so needle tenderizing, blade tenderizing, those are methods for which we produce non-intact product. When we started looking at this, because all of the processors then had to address E. coli 0157 in their hazard analysis as part of their HACCP plan, they also had to be able then, if they identified E. coli 0157H7 as reasonably likely to occur, they had to validate their system in order to ensure that the identified pathogen of concern was adequately controlled. So the objective of this particular study was designed to look at validating in-plant application of two different antimicrobials. One is lactic acid, and the second is beefside, which is an organic acid mixture of lactic and citric acid. They were applied at different processing schemes, either a single pass through a tenderizer or multiple passes through a tenderization, in order to look at the impacts of different tenderizing as well. Validation requires two components: the scientific component, which is often done in a laboratory, as well as the in-plant, which is the actual application in the facility itself. For this study, in looking at the actual scientific part, we already had validation that lactic acid is effective against 0157 in a laboratory setting, and we had validation that beefside is effective against 0157 in an implant setting. What we didn't have was the application of knowing how those worked in an actual facility. So in order to look at the second component of a validation study, then we looked at the application in the processing facility. We used previously identified surrogate microorganisms. These microorganisms were used as indicator organisms for E. coli 0157, so they're non-pathogenic organisms. We took them into the processing facility in order to conduct the second component of the validation study. These particular compounds, these microorganisms, have been shown to demonstrate identical thermal and acid resistance to E. coli 0157 in the previous studies conducted at Texas A&M and Iowa State. So in order to use these, we had to make sure that we followed the parameters for use and that we followed the parameters for FSIS allowing them into the facility. So they had to be used under the control of a microbiologist, and we had to make sure that we also addressed any sanitation and environmental contamination with these microorganisms. The particular three that we use, there are 5 that have been identified as the surrogate microorganisms. We purchased 3 from ATCC. The 3 that we used are listed on your screen here, the 1427, 1428, and 1430. We use these in a cocktail, and so we purchased these 3, we put them into a cocktail, and then took them into the facility. We made sure before we took them in, we did some environmental sampling, and we did environmental sampling after sanitation in the facility in order to make sure that there were no residual of the surrogate microorganisms, and there were not. We conducted this in 2 phases. Phase 1 included 3 subprimals: the bottom sirloin flap, strip loin, and top sirloin butts. We took a total of 12 cuts per each subprimal for this particular phase, and we treated 6 of them with beefside and 6 with lactic acid. Both the lactic acid and the beef side were already used in the particular processing facility, and we didn't change anything within their normal process because our goal was to look to see if we could use typical processing parameters within their facility, a commercial operation, in order to validate the use of the particular antimicrobials. So we allowed the company to do their normal standards as far as mixing of the antimicrobials. We then took samples of that and we would make sure that we put the information from their own monitoring for their parameters. And so the beef side was mixed at approximately a 2.4% concentration and the lactic acid a 2.9% concentration. We also allowed the establishment to process these in their normal processing manner. Now, the way that they do these is they will send them through a tenderizer. The tenderizer has an automatic spray system just prior to tenderization. For the subprimals, then, they would be sprayed and then tenderized. Depending on the specific subprimals, some of those subprimals would be taken off and would receive a second tenderization, and in some cases, a third pass through the tenderizer. Again, all following the plant's normal procedure, not what we had control of. Each time they went through the tenderizer, they were not resprayed with the antimicrobial. All product was only sprayed once with the antimicrobial as it went through. So we would inoculate. Following inoculation then with the microorganisms and the time for attachment, then the antimicrobial was sprayed. They were subject then to, depending on the cut, either the single pass or the multiple pass through the tenderization. One of the cuts then was also subjected to a marination process following tenderization. In the second phase of the study, we used strip loins. 6 strip loins were utilized for the second phase, and they were assigned to one of 3 non-intact treatments, either a single, a double, or a triple tenderization. Now, the reason we conducted the second phase is because after having finished the first phase, we as researchers had some question over the impact of what we saw as far as the internalization of the microorganisms. And so we wanted to know whether it was due to the actual number of passes through the tenderizer or if it was due to the combination of the passes and the tumbling or the marination process. And so we came back and requested that we be able to come in and do a second phase to the study, which was not initially there, to look at just passing the product through the tenderizer. In phase 2, we also agreed to only subject the product to a lactic acid spray. We did this because in the first phase we found that there were no differences between the lactic acid and the beef side, and so in order to minimize the disruption to the plant environment and to use the most commonly used antimicrobial of the 2, we chose to work with the lactic acid. For both phases of the study, all products received the single antimicrobial treatment, regardless of whether they had a single pass through the tenderizer or multiple passes through the tenderizer. Our average inoculum level was 7.8 logs CFU per centimeter squared. This is a much higher inoculum level than we would anticipate on naturally occurring product. However, from a research standpoint, we wanted a high enough inoculation level that when we knew we would lose a log to 2 logs just through the normal inoculum, we wanted a high enough level that we could make sure that we could identify the reduction as well as that we could truly look at internalization. And we also considered it to be what would be considered probably greater than even a worst case scenario for naturally occurring contamination. Beef side and lactic acid treatments both resulted in statistically significant log reductions of the surrogate microorganisms on products for all of the beef subprimals. So it didn't matter which subprimal we used, and it didn't matter which organic acid that we applied, and it didn't matter which treatment, whether it was a single pass or multiple pass. We saw reductions on the surface for all of the treatments, the beef side and the lactic acid. In phase 1, the reduction of surface microorganisms from the pre-intervention to the post-intervention steps for beef side and lactic acid were statistically equal across all the subprimals. However, the internalization of the microorganisms did vary. And so even though when we took the inoculation, we applied it to the surface, we allowed the attachment, we did the treatment, and then we looked at the surface level, they were the same. When we looked at internalization of how much was transferred from the surface to the interior, there was a difference. The interior counts were found to be higher for the bottom sirloin flap compared to the other subprimals. However, we should note that this is not unexpected because the bottom sirloin flap were the thinnest of the cuts, and they were the only product for which was marinated and vacuum tumbled, which potentially had then an impact to have a greater internalization of the surrogate microorganisms. This particular table shows you for the beef sirloin strips in phase 2 that had the single treatment, the double treatment, or the third treatment for tenderization. It shows that there were no differences if we look at single pass, double pass, or triple pass within the actual levels. So the data show then that if we look at those among all the tenderization treatments, it didn't matter. Once you had made that initial pass, they were all the same. Our conclusions are that tenderization and marination can transfer microorganisms from the exterior surface to the interior surface of whole muscle cuts, even following the use of an antimicrobial intervention. We also concluded that beef side and lactic acid are similar in their efficacy of antimicrobials applied as interventions during the production of non-intact beef cuts. And we confirmed and added data to the already existing literature that the surrogate microorganisms can be very valuable as used for validating in-plant processes without using pathogens in a processing environment. With that, I will close, and before I do, I want to make sure that we recognize and acknowledge this project was funded in part by checkoff dollars from the National Cattlemen's Beef Association and the Beef Board. So with that, I'll be glad to entertain any questions.